Going to nip over to our whiteboard. There we go. You know that we are working on the section dealing with 6.1, dealing with the area between two curves. So you might think, what's left? Well, orientation is what's left. We've normally been integrating, vertically, right? Y equals x squared, y equals x cubed, the area between two functions, which is the normal way you'd expect functions to put in. But you can actually have functions orientated in this direction, right, from left to right. And so this red one could be, x equals y cubed plus y, and this other one to its left could be, x equals 5 minus y cubed or something. And we're trying to find the area between the curves going horizontally. So when you do one of these, the little mystery rectangle that goes that way. And the formula for the area between a curve when it's orientated in terms of y's, as these are, right, x is a function of y, is the same formula essentially. The differences are, do you notice that you do from C to D, which means the start and finish of the integrals are y coordinates. And you have a function f of y, take away a function g of y. Now I've written it down as f of y, take away g of y, because it is. But here's the trick. The guy that's furthest to the right is the f. And the other one is the g. So when you look at a curve, look at the one that's furthest to the right and make that one the first function, the f of y, and the other one's g of y. But the process for doing it is exactly the same as before. So apart from orientation, which makes them look a bit weird, the process of finding the area between two curves is simply just finding the integral of the difference between the two formulas from the start and the finish value. And the questions we're going to look at today, for the most part, are going to look very similar to yesterday's, except they're going to be a whole load of y stuff in there, right? So I'm going to create a question that involves all 5 steps, and then we'll start looking at some of the homework questions, because in the homework questions, step 1 and 2 are typically, a lot of them are done for you. In other words, the picture's in front of you, so you don't need to use Desmos, and the numbers that you need, the start and finish and so on, are also in front of you. So you'd be beginning at 3 and at 4. So I'm going to have a function x, and it's going to be called, excuse me, I'm going to get myself set up here. There we go. So I'm going to have a function x equals, what will we have? Y squared plus y. Put that one in. Can't see this, but I'm doing this so I can tweak it if I don't get a good one. That's not bad. I can handle that. And the next one is going to be x equals, see what that one looks like before I tell you. And which one do I want? Maybe this one. No. I'm just playing about. We want to get a nice number, so if you could just hang in there for a minute. Right, I should have planned this before you came, but never mind. My next Calc 2 class are going to have a really easy time of it. So it's going to be y squared minus y is going to equal some guy I haven't made up a kilometre right now. Take away y squared, so it's going to be 2y squared minus y minus an a. So if I make a 3 should do it. Let's check that one out. Why didn't 3 work? 3 looks really nice. Oh. Okay. Yeah, Okay, that'll do. So after all that hard work, if I'd planned ahead, here's our two guys. And we are being asked to find the area between those two. So the first thing you do is you draw sketches of them, right? You know, because there is no picture here to do. And that's what I was playing about over there, trying to get one that worked. So I'm now going to show you. Here's one I made earlier. Yeah. So I went to Desmos, and one of the great things about Desmos that the TI-84 can't do is you can write functions down as x equals functions of y, not just y equals functions of x. So here are the two guys, y squared. Well, I put minus y. Okay, that might explain it. Y squared minus y, and the other one is going to be called 1 minus y squared, and they look like this guy. Now I'll zoom in a little bit. You see them? So the area between these two curves would be this kind of blob in the middle. So sketch is done. Second step, find the coordinates of intersection. Would you agree that that point there has a y coordinate of 1? So I'm drawing a little picture of this guy. And he looks something like this. And the other one's coming in here, goes something like that. And the green one is this one. So, and the other one is this guy. And I know that that point there is a 1. And can you see this guy here is at -1/2? But if you put the little thing over it, I got it. Okay, now let's get back to what our working would look like. So I had two functions, I put them into Desmos, and I found out that they look like these two guys. That's now a y squared minus y. This is 1, and this is -0.5. We're basically finished with step 1 and 2. Now, identify the f and the g. Right. If you do a horizontal, okay, like that, can you see this one is furthest to the right? So this one is going to be my f of y. And this guy is the other one, the other side, and he's going to be my g of y. And in this case, the f of y is 1 take away y squared. And the other curve, which is this one, is y squared minus y. So we've now identified who the f and the g are. In this case, f of y and g of y. And now we're going to integrate. And the integration process to calculate the area here is the integral from -0.5 to 1 f of y take away g of y dy. It's going to be the integral from -0.5 to 1 of 1 minus y squared take away y squared minus y. That's going to be the integral from -0.5 to 1 of 1 negative y squared minus y squared is what? -2y squared. Take away that guy is a plus y. These are essentially just power rules. With respect to y, 1 gets you y. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And evaluate it at -0.5 to 1. So what's that going to be? It's going to be a 1, take away a 2/3 plus a half, subtract I guess I could have called that negative a half, so I will. Negative a half, take away 2/3, negative half cubed, plus 1/2 times negative a half squared. God, that is ugly, isn't it? Okay, time for calculators. I might as well just put the brackets in as well. Let the calculator figure it all out. So it's 1 take away 2/3, add a half, close the brackets. Subtract, start another bracket. I've got negative a half, take away 2/3 times, I should do that in my head, negative an eighth, plus, basically plus an eighth. And the answer I get is that guy. If I go math, number 1, after a fair amount of work, I believe the answer is 9/8. Okay. Suppose I did a calculation, maybe on my calculator, maybe I tried to do it in my head, and the answer that I got out was negative 9/8. I got negative 9/8. Why should I be worried?
Because it's a negative and an area should always be positive.
Right, so we emphasized that yesterday. This represents a physical, real world area, so it needs to be positive. It has happened to me, probably will happen to you. The two main reasons that I got negative 9/8, the first one is I just can't count, right? I screwed up my adding, multiplying, whatever I did. And the second one is it's much more easier to do when it's orientated in the Y's, right? Is that I got the F and the G back to front. So the answer very often is just a positive value. So if I was in WebAssign and I got negative 9/8 and you know it's wrong, for your second guess, try 9/8. And if it works, all you've done there is pretty much the F is where the G should go and the G is where the S should go, right? You just got them switched around. That's been my experience, at least when I screw up. Are we okay with that general process then? Because it's very similar to yesterday, isn't it? You're just doing left and right instead of up and down, right? So it's the area between two curves from the left to the right instead of the area between two curves from the bottom to the top. Any questions before I move on? Okay, then next thing I'm going to show you is.
Actually, I have a question.
Great, whoever it is, I can't see who it is, but keep talking.
I was just making sure. So for f of y, or I think it's for f of y and g of y, one do you make sure is on the first and the second?
The one that's furthest to the right is always going to be the f of y.
Okay.
Right? The one that's furthest to the right, make him f. Okay.
Thank you.
In fact, let's look at this picture. This is straight out the homework, at least my version. Don't know if yours looks different. Can you see this is a curve going this way, this is a curve going that way. The shaded area is what we're looking for. Pretty mundane question. The only thing you're going to do is put the area in here, right? So we need to set this guy up. Okay. Can you see you're going to start from y equals -1 to +1? Can you see that? All right, so although you can't see me, I'm writing that down. -1 to 1. When you look at it, there's a red curve and there's a blue curve. The red curve is e to the y, and the blue curve is y squared minus 8. Which one of those two is the f of y, the guy I write down first?
E to the y.
Easy decision when you've got a nice picture, isn't it? Furthest to the right. Now that means it's going to be e to the y is the first guy, take away y squared minus 8 dy. And that's that one setup. I'll leave that for a minute. This is a version of 4. The limits of integration just mean the numbers you put in the integral sign, right? From y equals this to y equals that. What are the limits of integration in this picture? Y equals what number and finish at y equals what other number? What are the start and finish numbers?
0 to 5.
Right. For those that are having orientation issues, if you turn your head on the side, I know it's painful, it kind of looks horizontal and your brain sees it better. But would you agree that is where, oops, get that out of the way. Would you agree that is where y equals 0 is? And can you see it finishes here at y equals 5? Which one of the two curves that's mentioned is the f of y in this case?
F of y is 4y minus y squared.
Correct. How do you know that?
It's more positive than the other one.
Okay.
Like if
I
you
would
rotate
say
the
it's
graph-
more. I would say it's more to the right, but positive has the same effect. Yeah,
Yeah.
just a different way of saying it. That's nothing to do with us. That's yesterday's. That's a yesterday's one. Right. Question 7. See this one here? Question 7. You're not actually being asked to do the whole question. I wish they had. You're just being asked to set it up. So in this question, won't you go to Desmos and type in that guy, and then type in that guy? And then, oh, well, they told you one of the intersection points, but you'll figure out who the other one is. I'm making this up because I don't know, because I don't have the picture, but can we pretend it's 2? Just for argument's sake. Now, on Desmos, won't one of these guys be first and one of these guys be second, right? And so you'll look at your picture, and I'm making this up because there's a 50-50 chance I'm going to actually guess it correctly. Let's suppose that this guy ends up being, well, if I got little squares around it, I guess I don't need them. That's better. This guy, what's it do that for? Yeah, that's what I wanted, right? Would go first, and then, according to me anyway, this one would go second. Can you see that's not too difficult to judge? One of them's right, okay, so depends on the picture in front of you in Desmos. The one that's furthest to the right is the f of y. And then, I guess you could finish it, but they don't want you to. Question 8 is pure Desmos. Put that into Desmos, and it's going to be one of those pictures, and then we'll figure out what to do afterwards. So let's have a look. It's y equals 3 plus x cubed. It's y equals 5 minus x. It's x equals -1 and x equals 0. Right. So let's see what we can do with Desmos. Here we go. I'll start with just write it the way it was given. Y equals 3 plus x cubed. It's the first one. Oh, interesting scale. And y equals 5 minus x. And for some reason I can't see it, so just scroll back. Okay, I can see it now. Then I do what? X equals -1. And I'll do x equals 0. Well, we all know x equals 0 is the y-axis, so I'm going to zoom in. And here's the curve. Here's the straight line. This purple line is x equals 0. This green line represents the other one. So the region I'm looking at is this region here. I wish I had the feature where I could shade things in. Can you see the region that my mouse is zigzagging up and down? So you want to do the integral of that guy. One of the pictures should look something like that guy, and that's the one that you're going to pick. Let's go back to that one. Oh, I should have paid more attention, but evidently one of those pictures looks like it, because some of it was hard for me to remember. Now, once you've done that, don't you just set it up with the usual way and get that? Do you notice in this case, do you notice that funny little yellowy, whatever color that is, rectangle? Isn't that just so you can see top guy, bottom guy? You know, this guy would be F, this guy would be G. That's all that's there for. That's one of the guys we've done before. That's pretty standard one. That's a standard one. We don't need to do that. Okay, here is one that's orientated in our direction. Can you see it's x equals 4 minus y squared, y squared minus 4? Okay. And one of these pictures is going to look like it. I think I should be able to do that one. Let's move that out of the way. Okay. Let's kill these guys off. So we have two functions and we're being asked to find the area between them. And the first one is x is 4 take away y squared. And then the second one is going to be x equals y squared minus 4. There we go. Don't need that. Move this up a little bit. So I'm looking for a blob, right? This blob here. And what do I know about it? It goes from negative 22 and negative 44, and negative 22, negative 44. Where are you? And you can't see it, but that's picture number 1. Okay, so the integral will go from negative 2 to plus 2. Would you agree the black one is the f of y? And the red curve will be the g of y. So if I was setting that up, which I'm now doing right now, it'd be from negative 22, 4 take away y squared, which is the black curve, subtract y squared minus 4, which is the red curve. Let's kick out of this guy. See what this guy looks like. Yeah. Can I do dot, 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 and that? Would you agree it's not that hard to solve? Pretty straightforward integral. Just make sure to subtract things properly. And that one's pretty straightforward. That one's pretty straightforward. This one is question 15. And so it's x equals 6y squared and x equals 20 plus y squared. Okay. So I want to do kind of all my steps on this one. So that means I'm going to jump around a lot. I've got something in the chat that I need to know. Okay. So, can you see Zoom? Hey, Desmos, I should say. Okay.
Yes.
So that question that I just wrote down was x equals 6y squared. And the other one was x equals 20 plus y squared. And we're being asked to find, it's interesting, to find the area between them. Okay. Do you see that it's over here? This area here. It looks a bit like Star Trek officer's badge on its side. Right, see there? So I need to know that number there. And that guy has a y coordinate 2. And by symmetry, I'm pretty sure that guy has a y coordinate, and it does of -2. The purple guy is definitely, if you want this region here, the purple guy is to the right. So that makes the f of x 20 plus y squared, f of y I should call it. And the g of y is the other one, which is 6y squared. So try and see where I got those numbers. You start at y is -2 and you finish at y is +2. The f of y is the purple one and the g of y is the green one. Now you put that package together and we're on to step 3, which is basically integrate. That guy is 20 plus take away that guy ends up being what, -5y squared. Power rule. Okay, what do I get? 20 times 3 plus 5/3 times 3 cubed. Take away 20 times 3 minus 5/3. Why did I put 3 there? Who knows? Just I caught myself. So there. For some reason my 3 turned into a 2. Oh, that guy's going to be 40. 2, 4, 8. That guy's going to be 40/3. Take away -40. -8, and 40/3. 40, take away 40 gets you 80. That guy kills that guy off. The answer's 80. Any questions? Or is this beginning to become a little bit more like a process? And as long as you know where the information is, you can do it. We good? Right, so what's left? Well, what's left is they're going to muck about with the 2 functions. Here's an example of question 16. The information is not given in a form that's going to make it usable. If you want to do this, don't you need to have functions of x? And so these are the 2 functions that you're going to work with. Do you see all I had to do is rearrange this one? And if I move on to the next one, no, nothing wrong with that one. Nothing wrong with that one. And then obvious, no, nothing wrong with that one. I thought they did another one. I am wrong. Okay, I'll give you one. Suppose I give you that one. I want to know the area between those 2 curves. I need to figure out a way of adjusting them so that they both agree. For instance, this fella here, can't he be turned into cube root of y? And I can keep that one alone. Do you see you need the same function in both worlds? Because it's either going to be f of y take away g of y, or it's going to be f of x take away g of x. You can't have an f of y and a g of x, right? You can't mix and match the variables. So that's just a little algebra trick that is, I wish they'd more than that, but I'm wrong. So what will we pick? Oh, let's do a trig one, of course. Y equals cosine of x. So this one is question 19. Y equals cosine of x, and y equals 2 take away the cosine of x. And we're being asked to do it from 0 to 2 pi. Right, so this is just all bets are off kind of thing. So the first thing I'm going to do is find out what that guy looks like. I've got a feeling I know what it's going to look like, but I could be wrong. So y equals, I believe this Desmos takes cosines. It does good. And we are interested in only from 0 to 2 pi. No, okay, pi. Should be hidden in here under symbols then, is it? Okay, where's pi hiding, guys? Somebody must know where pi is. Where is
You
it?
just type in pi.
Oh, I did. Is it pi without capitals, maybe?
Yes, lowercase.
Oh, that's my mistake. I put capital P. Okay. Now, we look at this guy. There's a lot of duplication going on, as I can clearly see that. Maybe here a little bit more. Right, I'm just trying to isolate so that there's not too many distractions. Yeah, that's probably the best. Can you see the x-axis going this way, the y-axis going that way? And we're basically looking like Mick Jagger's lips, if you know what I'm talking about. I'm old, I remember Mick Jagger. He's still alive, which is an amazing thing, considering what he must have done to his body. Right, so the integral for this one is going to start at 0, and it's going to finish over here at the green guy, who's 2 pi. Would you agree the red one is the f of x? Looking at this picture, the red one's a high up one, f of x. So that's going to be 2 take away cosine x. And then you're going to subtract the other guy, who's just cosine of x. And I think we've done pretty much all the hard stuff. That's step 1 and 2 done. So the area is integral from 0 to 2 pi because of this. F of x, because that was higher up. Take away g of x, that was the other one. You put this together, you end up with that guy. That gets you 2x, take away, oh, almost done something wrong there. What is the integral of negative 2 cosine x's? Negative 2 cosine x's. What's the integral, the antiderivative? That's kind of worrying. Okay. There we go. Evaluated at 0 and at 2 pi. So I get 2 lots of 2 pi, take away 2 times the sine of 2 pi, subtract a whole load of nothings. What's the sine of 2 pi?
It's 0.
So the answer ends up just being 4 pi, which is actually a very elegant answer. So the Mick Jagger lips one, right? The one that looked like this. Its area is 4 pi. In fact, it's not that unusual when you do sines and cosines, at least, for the answers to have pi in them. Does it seem reasonable, you know, angles and cosines and sines and pi kind of play well together? Not unusual. Okay. What left then? I think I've covered all the good stuff. And if we have, gives me a chance to intro tomorrow's stuff. I'm just scanning through it. Yeah. The ones I'm not doing are pretty standard. WeberScience kind of generous to you. Many of the questions already gives you a pre-drawn picture. I wish there was a fewer of those and more where you only got the algebra and you had to do it from scratch. But I can live with that. Okay, our next section then. Volumes. To give it its full title. They're called volumes of revolution. So I want you to imagine, I guess if you're an engineer, it's a little bit easier to imagine, that you had the x-axis is the center of rotation of an object. And I have a function called y equals f of x. And this function is going to start at a, and it's going to finish at x equals b. And it's going to be rotated about the x-axis. So if you imagine that curve rotating about the x-axis, when it does so, and I'm very bad at drawing, but I'm going to do my best. That's not bad. Can you imagine what it would look like? Well, it would look something like this. When you end up with a solid, it's called the volume of revolution, right? If you take a curve and you rotate it about the axis, the x-axis, do you see you would make a, I know it looks a bit like a pawn in a chess piece, right? That would be my description of it. Can you visualize my very bad drawing of what that would look like if you rotated it about the x-axis? Wouldn't it be nice if there was a way we could find the exact value for the volume of that chip? That's essentially what 6.2 is going to be about, finding the volume of shapes that are formed by rotating a curve about some axis. In this case, it's the x-axis, but it could be the y-axis, could even be a line like x equals 1 or y equals 1. And we are going to look at how to find that volume. So, situation 1. If it's a single curve, as this one is, y equals f of x, and it's about the x-axis, then the volume v is the integral of pi, whatever f of x is, squared dx. And you would do it from wherever you started and finished. Would you agree that's a very simple formula? You would have thought it might have been something a lot harder. So let me see if I can prove it to you. Maybe not a perfect proof, but at least a pseudo proof. Can you imagine me randomly picking some point, let's call it x. If you slice this 3D shape and you looked at it from this side, and imagine this was a little sliver and it was delta xy. If I cut it that way, wouldn't you end up with a disc that would look something like that, a bit like a coaster? Can you imagine slicing a little piece of it? Now, isn't the distance from there to there called the radius? And isn't the distance from there to there going to be delta x, right? Put a little r for radius. So what is the volume of that one little disc? Well, the volume of one little disc is pi radius squared height. Remember the volume of a cylinder? And isn't that basically just a very tiny skinny cylinder if you orientate it? And so it's going to be pi r squared delta x. Wait a minute. Isn't the distance from here to here the radius? From there to there. But isn't that the same as the value of the function? So the volume of one of those tiny little cylinders is pi f of x squared dx. Can you see where it's coming from now? Are we good? Right. Well, let's put a function in. This is what's finished for today. Let's do y equals x squared, and we'll do it from -1 to +1. Now, the only reason I'm shading that is to just make it a little bit easier. If you rotate that shape around the x-axis, you would probably get a thing that looks something like this. And the only shape I can think of, do you know those funny shaped yo-yos, or the things that people who do go on ropes and they throw them in the air and they catch them? Do you know those balancing things? It looks a little bit like that to me. So it's got like a circle on this side and a circle on that side. You can see I filled that. Well, according to our formula, that's the volume. I typically bring the pi outside and just integrate this fella. And if you do, oops, her rule, can you trust me? Because I'm running short of room, you get 2/5 pi. So the volume of that little guy here, that 3D shape, is 2/5 pi. And almost every question that you're going to get is going to have a pi tagged on at the end because of this pi in the formula. And we want exact answers, so don't try and turn it into a decimal. That means, provided you have a shape for the designing curve, right, the f of x, can't you find the volume of any weird shape? It's just going to be pi, the function f of x squared, from start to finish. So if you're, I don't know, if you're creating some really weird, I don't know, component, and you wanted to know its exact volume, and you were using one of those machines, you know, those programmable lathe machines, wouldn't you be able to know what the volume of that shaped object was going to be even before you started cutting it? And remember to say your second namespace, your first name. And that is us for today. I'll see you tomorrow. And everybody should have got report 2. Send me an email if you didn't with the email you want me to use then.